Sometimes you wind up having to use integration by parts more than once to do an integral. And this is a good example of that. So here we've got two things inside of this integral. We've got a quadratic and we've got a trig function. So if we look at our LIATE, the quadratic thing is going to be here because it's an algebraic expression, and the trig is here. So what we want to do is, let me switch back to black, let u equal the x squared, and then dv is going to be cosine 3x dx. All right, so let's do this. Du then is going to be 2x dx, and v is going to be, let's see, if you integrate cosine, you get positive sine. So this is going to be sine of 3x. But we have to divide by that 3, so we get a 1/3 there. All right. So now let's rewrite this. This is going to be uv. So u and v together, I'm gonna go ahead and stick the x squared in the middle. So uv is going to be 1/3 x squared sine 3x minus integral v du. All right, my v du, that's going to be 2/3 x sine x dx. And let's see, I could leave that 2/3 inside, or I could bring it outside. It really doesn't matter, but I think I want to bring it outside the integral. So let's do that. So 2/3 integral of all that. So using integration by parts, we've gone from this to this, but this is still something we need to use integration by parts on. So I'm going to do that again. I'm going to come down here. I'm going to let u, for this one, tell you what, I'm going to do this in a different color. For this over here, I'm going to let u equal x and dv equal sine x dx. You might say, is it okay to reuse my u and v? And if you wanted to, you could use capitals or something like that. But it's okay to reuse u and v because notice, we only used them briefly in here in order to rewrite it. So we're kind of done with this u and v. If you're a computer science major, you might think about the scope of the variables. It's like these were defined in here, but outside of the box, oh, we no longer care about what that u and v were, or what that u and v, what they were. All right, so let's see. So du is going to be dx. And integrate this. When you integrate sine, you get negative cosine. All right, so now I'm going to recopy this. Maybe I should recopy it down here where I've got the full width of the screen. We've got 1/3 x squared sine 3x minus 2/3 of, I'm going to put a big bracket in there because now inside of there we have to do uv minus integral v du using this u and v. So from here, let's see, uv is going to be minus x cosine x. That's my uv. Then I'm going to do minus integral v du. So minus integral of v, let's see, that's minus cosine x, and du is just dx. All right. So let's clean that up as best we can. 1/3 x squared sine 3x. Okay, now this 2/3, I'm going to distribute that in here, so I'll get plus 2/3 x cosine x. And then over here, I've got negative 2/3, another negative, and another negative. So altogether, that's 3 negatives, so it's minus 2/3 integral of cosine x dx. And so now I can integrate that. I'm just going to be a little lazy and only do that one step. Minus 2/3, integral of cosine is positive sine. And I don't need the dx anymore. Positive sine, then a plus c on the end. I was thinking I would need to do something more to simplify it, but I don't. I'm going to leave it like this. So that's using integration by parts twice on one problem. Now, this can get tedious after a while. I mean, this wasn't exactly a short problem, but if you come back up here and look at it, if this had been, instead of an x squared, if that had been an x cubed, we'd need to use it 3 times. If it had been x to the 5th, we'd need to use integration by parts 5 times. And that gets old really quick. Fortunately, there's a method that we can use for this called tabular integration by parts. And we'll learn about that in an upcoming video. But that will make much shorter work of this type of problem.